This webinar series is really for the basic user that's either never done a lot of modeling or hasn't used SMS in a while. So I am going to be covering the SMS interface, a few of the buttons and things that you can do here and there. What I'm going to be using is SMS version 13.0.5, which is available to all of ASIC users through the app portal. And on that main webinar page, I have a link directly to it, so you can grab it. If you have version 12.3 on your machine, it should be close enough for this webinar. We're going to be having another webinar in the late summer. I'll be going into some more advanced features, and those features are probably only going to be on version 13.0, whichever we have available at that time. So to start off, I'm going to be going over the surface water modeling system, what it is, what we use it for when we're using it with our coastal modeling system. This is a little bit older view of our coastal modeling system, how they interact with a wave model and a flow model, and each one does its own components, and then they talk to each other so that we can provide feedback from one to the other through whatever time period that we're going to be simulating. So the SMS, we use it in a lot of different ways. There's a preprocessor as far as getting survey files and putting everything together, getting datums pretty much in order. That's what we're going to be covering today. And once we get those files together, then we can apply them to various models, not just CMS, but the other models that SMS supports. And there's quite a handful. There's probably 12 to 15 different models, if not more, that the SMS can handle at this time. And then we can also do some post-processing once the simulations are complete in the form of creating film loops, animations, different plots, doing operations on the data that we load in. And we'll get to that as the week progresses. And you can also connect this tool with other outside tools as well, such as AutoCAD, ArcGIS, other different files. We support those formats as far as reading them, and we can write out shape files. I don't think we can write out AutoCAD type files. So I'm not going to go over this slide in detail because I'm going to be covering it in just a few minutes, but basically there are different features on the interface that we're going to be going over. Basically, there's a menu bar at the top that has a lot of pull-downs. There are several modules that can float around that address specific tools. We'll be going over those. You can move those as you want and make your window look the way you want it. You can resize things so that it's the way that is easiest for you to work with. So there's the menu bar, there's the graphics window, which is basically where everything is shown as far as graphically, and then everything that is loaded into SMS shows up on the left-hand side here in what we call the data tree. And so in this example, we've got a quad-tree grid with a couple of different data sets. We've got a simulation that was run named Alt5 that has several different solutions loaded. We have some map data. We'll be going over what these individual things are. And then we have the simulation that was run and how it was set up and interacted with each other. At the bottom here, we have time steps window. So as you scroll through these different times, then the graphics window will update with the appropriate information. A little bit of status information as far as the X and the Y, the Z value, and then whatever the scalar value is that you're looking at over here, whichever is selected, will show up here. And we'll also have some more information here at the top as well. So there's a few different toolbars. This is a static toolbar that's basically pan, zoom, and rotate. And when we talk about rotating, we talk about oblique views so that you can look at it from different angles and things like that. There's a dynamic toolbar that basically it changes. The options within it changes depending on the models or the type modules that you're working with. So if you're working with triangles for AdCert, you'll have different options than we do for CMS, which are mainly finite difference type tools like rows, columns, cells, splitting, dragging, selecting, things like that. And I'll be going over this in detail a little bit later on in a demo. So there's a data toolbar here that you can do some calculations on distance and loading in maps and things like that. Some other toolbars that show up have different macros, so it's shading and contours, vectors, how they appear on your screen. We'll be working with that a little bit. File, there's opening, saving, standard things, display, refresh, and frame to the extent. There's display options, and then a plan view. So if you had gotten into some kind of rotated angle, you could click this key to get back to a flat, looking down type of view. Then the modules, there's different ones. So there's 2D finite element grid, 3D, 2D finite difference grid, 3D scatter module, the map module, and some other things we'll be going over a little bit later on, and some things that we just probably will not cover at all. It doesn't really pertain to our type of information. So I kind of went over these a little bit. There's the mesh, Cartesian grid, scatter point, map, particle tracking, annotation, measuring, and all like this. You have access to the PDF, so you can go through these if you want, and then I'll be showing a little bit of that a little bit later. So things that are specific to CMS flow and CMS wave type grids are these Cartesian and quadtree grid tools. So you'll be able to select individual cells or rows or columns and those, get the average values, things like that. Sometimes with Cartesian grids, you can split the row into multiple rows or columns. You can move the edges around. Cell strings, we'll get into that a little bit later, but basically that is where we apply forcing conditions through like boundary conditions and such. Grid frame, I'll go over those tools in creating the actual domain that we're going to be working with. Contours. Then there's some map data tools that we'll be using more and more. There's selecting and creating feature nodes, vertices, feature arcs, polygons, and 2D grid frames. And one thing to note is that they look alike, but the selection tools usually have an arrow pointing to the individual things, and the ones that don't have an arrow are usually a creation tool. So you'll have to make sure you're on the right tool to actually select one after you've created it. That's a little bit confusing for some people at various times, but sometimes it's needed. So. Some scatter tools, when we're pulling in bathymetry, different things, they come in the form of scatter data, and so you'll be able to select individual points, create break lines, look at the triangulated elements formed by the points, and then you can flip the edges if you need to a little bit later on. We'll be getting into that a while longer later. Can you guys mute your phones if you're not? I appreciate it. So the data tree basically holds all of the data that we have loaded into SMS. You basically would just click on any of these data sets that show up, and then the graphics window would change accordingly. And then you can change through some other tools how the contours look and how the vectors look, things like that. We try to use the SMS as a complete interface, basically from start to finish. There's a couple of things that are a little bit easier in other tools. We've gotten a little bit better in doing a couple of things with the SMS over the years, but still you can do any part of these within the SMS or in your favorite tool as you need. So that's from taking in profile lines and making them into bathymetry points. You can load in aerial photos for visually locating your area, or when you're making a report type plot for a customer, they can easily see where they are. You can start with initial coastline arcs. Then we'll build a 2D grid frame, import all the data and bathymetry, and it'll look something like this. And then we can go in and add resolution, different things. We'll be showing that throughout today and tomorrow. So when you pull in the scatter sets or any file, SMS tries to interpret what kind of data is included in that. And if it doesn't really know, it'll bring up this file import wizard that basically says, I've got some kind of columnar data, and I want you to tell me what is what. So we go in and we can say, okay, well, this first column, we can change this tool right here to be the X or the Y. Sometimes you'll get the eastings and northings, and sometimes you'll get northings and eastings. So you can flip those around as you need. And then point to Z is usually the depth. So you would select the Z for whichever column. And if you had other columns with other data, then you can bring those in as well, and they'll show up in that data tree. When you get the data in, they come in as a triangulated network of points. And so you can see here we've got some points that are brought in over a basic little topo map that we loaded in. And then you can do operations on that. You can look at the contours of the points, or a lot of times you'll see where there's a barrier island here, and we need to get rid of some points in between, things like that. And I'll be going over a lot of that later. So another thing with the SMS is visualizing. So you can look at the individual points, you can look at the current points, and then you can even turn on a little bit of shading and look at things in an oblique direction to get a better view of what your data looks like. And this is just a little screenshot of that. We turned on the lighting a little bit so you can see a little bit of the depth of the channels through here and the shoaling of this area. This is for Humboldt Bay, California, and some of the tidal flat areas and how they're represented. And hopefully through this method you'll be able to see any kind of issues that might be happening with your data, things you need to get rid of or improve on. Okay. So we're bringing in some LiDAR surveys, and you can visualize those. A lot of points in these surveys, and we've developed a few different ways of dealing with the survey information and bringing it in a little bit more efficiently than we have in the past. I'm not sure if we'll be getting into some of this, but later in the summer, as I mentioned earlier, we're going to be doing some more advanced features for the CMS and SMS. We'll probably get into a lot of visualization tools for LiDAR and some other things and how to work with that. One of the things you can do with the scatter sets is to create break lines. So when you bring in your points and they're brought in, they're automatically triangulated. You may get some of the points that cross a channel that will block some flow, and so the break lines will allow you to generate smoother bathymetry and allow that flow through there. Bringing in multiple scatter sets, we typically have several data sets for different areas. We'll want to merge all those together, and each one of those will have, be for certain areas. And so you would want to merge all those together with a common datum, and then apply that entire bathymetry set to the final grid. And we'll be going over all of this type of thing later today. So this is very important in getting all your bathymetry surveys and things like that, all talking to each other in the same datums so that we can be as accurate as possible. So when you merge the scatter sets, you end up with some elements across areas that you might not want data. So we can represent these areas of the barrier island with a certain value to say that they are inactive. And so we don't really need the triangulated information from this point to that point. So we can go through and select these triangles and then get rid of them. We'll be going through some examples of that in just a few minutes. So you can work with different types of images, topo maps, aerial photos. You can overlay your data onto those images and even make animations of this. So a lot of the different interface pull-down menus I'll go over in the demonstration. But there's a dataset toolbox that has a few little tools that we'll be using throughout this portion. One of them is called the data calculator, and that's important when we're working with our datums to do some conversions from feet to meters and things like that. Contour options for changing the way things appear, building a film loop. I'm not going to go into every one of these, but there are different things to be able to accomplish different tasks. So the model control within for a CMS type grid looks something like this. We have several different tabs for different things. I'll be going over this in a few minutes. The Wave interface has a little bit different set of pull-down menus, but it's all interacting with that type of information that it needs to for the Wave model grid. For the waves, you'll need to load in spectral energy, either in the form of what's shown here with true energy from a gauge, or if you have bulk information from other sources, you can add and work with that as well. There's different information for the model control for the CMS Wave model, and we'll be getting into that probably on day 3 of this. Dataset Toolbox, I mentioned the data calculator. There's a few other tools in here that you may need, converting vector data sets to scalar or vice versa, merging data sets, sampling time, things like that. For the most part, in this basic overview, what we're going to do this week, we're going to be covering the data calculator and maybe one or two of these other ones. So as we mentioned, the data calculator, you can do different things. So based on anything that you've loaded, you can perform operations on. Basically, you would select whichever one of these data set entries, and you would add that expression to the calculator window, if I can get back to it. And you would just load a expression here, and then compute that, and you would wind up with another data set. So every cell in the grid that you'll be working with will have a value based on that computation. I'll show that shortly. Rotating your grids for Cartesian grids. This is something we may need if we have an existing wave grid and we want to create a flow grid directly from that matches the domain. We'll begin a little bit later on, but that is possible. Projections, you'll note if you've used SMS in the past that projections in 13.0 and later look completely different than they did previously. We'll go into a little bit of this. In my opinion, it's not quite as easy to select your projections as it used to be, but they had their reasons with the tools that they were working with where they needed to move to a different setup. So we'll be going into that a little bit, and you can set these projections, and they're all the standard projections as you might find in other software as well. So some post-processing type things, annotations, images, animations to these plots. A sample image over here, you can have a logo, a north arrow that basically will change based on the oblique angle that you're looking at. scale bar that's dynamic. You can zoom in and out, and it will scale these numbers. And then through time, you can go through your different information that you want to show. An example of a contour and vector plot, Ocean City, Maryland here. You have a list in contours and vectors all showing over a map. So you can also export any of this information within the SMS to Google Earth in the form of a KML or a KMZ overlay. So you can save those out and then load Google Earth with that. Immediately it'll zoom into your area and you can show the information or even a film loop. And so I think most everybody on this call are Corps of Engineers. And so if you want to obtain the SMS, we have a link on the SURF website under Products SMS. And then there's a help desk that is housed here at ERDIC. And you can reference that SMS at ERDIC USACE Army Mill to get passwords and things like that. If you have any issues, just contact me directly, and I'll help you get your passwords and things to the right location. The SMS is on the app portal, and so right now we have access to version 11.2, 12.3, and 13.0. We'll be adding in a couple of updates for 13.0 as they come out. I think the actual last version that's available through Aquaveo is 13.0.8, and the one that we have available for ACID is 0.5, so we're a couple behind. It usually takes about a month to get each update approved through ACID, so just bear with us if there's some fixes that they're going to be addressed. We'll try to get those to you as soon as we can. If it were up to us, we could get you directly, but it takes a little while for the approvals to go through. So the next little section is just going to be mostly over the coastal modeling system and its features, things like that. So our objective with the coastal modeling system is to give to every engineer a system that they can use on their desktop. There are other tools that are mainly involving the high-performance computing or things like that, but we try to give this tool so that we can quickly bring up to speed and get a new project going really quickly, and that's on PCs. A little diagram of the scales of coverage for the CMS models. So time scales and spatial scales, and CMS is this big blue oval that kind of goes here. So we're going from seconds and minutes to decades at this point. We're trying to move on up to centuries, but for the most part, we're in the years, up to about 10 years. And then on the scales from meters all the way up to about 20, 30 meters, depending on your area. Some of the features for CMS Flow, it's a finite volume method of computation. It does conserve mass. Pretty stable for the most part. Of course, you can crash the model with bad input, so we try to do the best job that we can. It's coupled with an inline spectral wave model called Siemens Wave, so we do have wave and current interactions in both directions. There's an inline sediment transport, morphology change, and we are using a non-equilibrium sediment transport model. We call them the NET as our default. There are some other options if you want to try them out. We have some nesting. I'll go into that in a few minutes. And the types of forcing that we have are water surface elevation forcing, river, wind atmospheric pressure, tidal constituent forcing, either from a database or from a constituent list that NOAA keeps up. And we do have the capability of doing single or multiple sediment grain sizes, working with different layers in the bed. We'll be getting into most of that in later webinars for the more advanced features. So going over the grid options, so if you're familiar with SMS in versions before 12.0, we had Cartesian Grid, which is this one on the top, and that mainly had resolution at a certain point, and that resolution had to extend in both directions of the way the grid cells were lined up. So you get them all the way to the lateral extent in both directions, and that sometimes gave you very small cells in deep water and caused some issues. So we looked around and we finally implemented a quad tree type grid way to store data sets, and so that way we can increase the resolution near the, like in this case, near the jetties, and then outward without really affecting the cells in deep water. It's a lot more efficient, and you can get much smaller cells without really causing any problems in other areas. So that quad tree grid is available in 11.0, I believe, of SMS and later. And then Cartesian grids, they're still supported in SMS, but right now they're not working. I'm sorry, can you guys mute your phones? We still have a couple of people that are not muted, and I've tried to mute everybody. Thank you. There are different solver options. There is the implicit solver and the explicit solver. The implicit solver can go from about 10 minutes and up. So we try to keep that around 10 to 30 minutes. You don't want to go too high because you still need to be able to effectively work with the processes such as water forcing, water level flow, and those are usually on like half hour to hour. They're changing quite a bit. So you don't want to make your time step too large. That way you would not be addressing those type of issues. Typically, we run between 10 to 15 minutes with the implicit time step. There's also another solver option if you have areas with extensive tidal flats that would wet and dry within, completely wet and dry within the 10-minute window. You might want to explore using the explicit option. It's a little bit different scheme, but the order of magnitude for the time steps is much smaller. So we're down to about a second, and realistically we are sub-second on those time steps. So half a second to 3/4 of a second time steps. So the different terms that we address with our hydrodynamics and CMS flow, it's the depth average current velocity, total water depth, water surface elevation, we have gravity included, atmospheric pressure, we have precipitation and evaporation included at this point, Coriolis, eddy viscosity, wind and wave stresses, and then bottom stresses from the waves. Just an example, one grid that we set up for Factory Channel in Texas is relatively quick. We got it up and running in just a matter of hours, and within that time we were able to get a pretty decent water surface elevation validation, and the velocities weren't so bad in a couple of different places. Usually you want to put a lot more effort into these grids, but this was just an example of getting this one up and running quickly, and then seeing what kind of an answer we could get. So I mentioned earlier the nested grid capability. So that's basically, you might have a large grid that somebody else worked on, and you have a new project that you want to do that's included within that area. You might be able to take that larger grid and use the forcing or the solutions that came out of that grid to force your smaller grid that's done at a much higher resolution. And so this is just a idealized mock-up, but basically this is a larger grid. We have a smaller grid with a lot more resolution in some areas, and we can extract the information, the solution from out here to force along these edges to get a better answer with fewer cells. So I'll go a little bit faster. Talking about Siemens Wave, a few of the key features included with that, we have shoaling or refraction, reflection, and diffraction. Bottom friction, white capping, wave break-in different options, generation of waves by wind, interaction with the currents and other waves, transmission, run-up overtopping, ways of applying a muddy bottom to get different dissipation, this automatic grid rotation based on the wind. It will automatically do what it needs to get the waves going in the right direction. And we have a fast mode where you can speed up the answer by a certain factor to get a quick answer and see what's going on. And then when you're ready for production mode, you can turn it off and go back to the full mode. One example, we have wave generation by winds. We have Hurricane Rita back in 2005, and the model was run, and we have, you can see here the vectors of the wave energy going in different directions, and all that was based on the winds that were generated. A little bit of an example with the wave dissipation of a muddy coast. So we have certain area of the coastline specified with certain coefficients to represent a muddy area, and the rest of it is without. We have some plots here of the answers both with and without. It's hard to read on this diagram. I'll try to get a better one for future. But where we have the muddy bottom, we were really overestimating some components, and then once we got that, we were matching pretty well. So that was added a few years back, and it's been a good add for us. Sediment transport for CMS, we use different models. Non-equilibrium is what we're using currently at the moment as our default. But with that, you can choose different sediment transport formulas that do different rates of transport, and you'll need to just adjust those to your area when you're doing validation to see what does the best job for you. We do represent hard bottom if it's applicable to your area. So in a lot of areas you might have rocky outcrop that's underneath a set amount of sediment. And you can specify what depth that it's located at, and then our model will stop all sediment transport at that level basically. There's avalanching when we have sediment transport going on, so if you have large areas that are falling in, we'll represent that a little bit better. Multiple sediment sizes are available. We're not going to go into that on this particular webinar, but at a future webinar we will. Some of the feeds that you can expect with the implicit model. We have one case here, 33,000 cells for Shark River. That's the demo that we're doing today. Basically, we did about a year and just over a day of computation time. Other cases, Shinnecock had 53,000 cells. We had a year done in about 1.4 days, and another one with 11 cells done in only 7 hours. So it just depends on the domain size that you have, the number of cells, and the forcing type as to how slow or fast your model is going to go. There's a lot of documentation out there. We have the CERC website and our wiki website. So the CERC website has a lot of different pages on it. We try to give as much information as we can. And this links to our wiki as well, where we have individual pages that we try to keep up to date. It's a little bit easier to have updates on a wiki than it is to go through the whole publication process and print out a new user's manual or things like that, even though we still do that from time to time. So we do use both of these a little bit, and so we have a lot of information about these locations for you to go through. And our email address and phone number is located here. If you have any questions, feel free to contact one of us, either myself or Hong Hai. Tanya Beck is our program manager. She may be able to help with some other questions. For the most part, for CMS-related questions, if you come to myself or Hong Hai Lee, that'd be great.